Number 13, which is this week's lecture, and today we will be talking about recursion and the recursive methods. Recursion mean recurring, doing the same thing again and again. It's the literal meaning of that one. So we also have these kind of the functions. Don't worry about this mathematical function, okay? But this is the way that we have the function. It is f of n, function over some value of n. And then we are saying that if the value of n is 0, the answer is 1. The value of the function is 1. And if it is not 0, then we are calling the same function again, n multiplied by f of n minus 1, and this is actually a factorial function, factorial. You know, if it say 3 factorial mean 3 multiplied by 2 multiplied by 2, 3 multiplied by 2 multiplied by 1. Understand? So this is a mathematical way to write that particular specific factorial in the mathematical language, where n is a positive number. We also have some condition on the n, what could be a value. It cannot be a negative value. Factorial of 0 is 1. That is the mathematical rule. Factorial of 0 is 1. So the base condition, when the n is 0, it is 1. Otherwise, we as J said that n multiplied by 1 less than of the function of that value. Okay. For example, this is the fraction, this is the recursion part, because we are calling in the definition of this function f, we are calling the function f again. So when you say f of 6, actually it will generate 6 multiplied by f into f of 5, function of 5, because here we say that n, whatever that n is coming, 6 multiplied by function of 1 less value of that one. It will continue unless and until we reach to this particular specific condition that n becomes 0. Once n becomes 0, it will give me 1. So once it becomes 0, now we want to find out the value of the function of f of 0. So f of 0 is 1 by this definition. So this will become 1 multiplied by 1. It means it will give me back 1 to the previous function. Now the value of the function of 1, f of 1 is 1. 1 multiplied by 2, it will give me back 2. Now the value of this f of 2 is 2. 2 multiplied by 3, it will be given back to the previous one. So because we need to give the value function, we want to find out the value of the function at value n 6. That depends on the value of the function at 5. That depends on the value of the function at 4. That depends on the value of the function at 3. That depends on the value of the function at 2, then 1, and then 0. But when it becomes 0, we have the value that will become 1. 1 multiplied by 1, the answer is 1. It means the function value of the function at 1 is 1. That will be replaced at this particular specific point, and 2 multiplied by 1, and that will become 2. And then this particular specific value 2 is going to be returned as a value of the function of the at the value of n is equal to 2. So 2 at 2. Now this particular f of 2, it has been replaced with 2. 2 multiplied by 3, answer is 6. So 6 is going to be replaced at this function value at 3. 6 multiplied by 4, 24. Now this f of 4 is going to replace by 24. 24 multiplied by 5, that will return back the value of the function at the n value 5, 120. And then finally we will get back the value of the function at 6. It means that we have computed the factorial of 6. 6 factorial. Understand? No understand. Why? Ask your question. Confusions. Speak up your mind. Why are you so? Because it is maths, we can't understand. Sorry, we shut our minds. We can't understand. Oh, sorry, this is a math we don't understand. 2 plus 2, do you know that?
4.
This is also a math. And you know that.
That's simple maths. I don't think that.
So I'm just saying that this is a definition. F of n is equal to n multiplied by f of n minus 1 if the value of n is not equal to 0. If the value of the n is equal to 0, the value of the function will be 1. Now, starting from this particular specific point, we have reached at this point based on this definition. We started with the n is equal to 6, and when it is n is equal to 6, we are saying that the value of the f of the function at the value n6 we can compute only when we know the value of the 5, value of the function at 5. Yeah. So we say 6 multiplied by value of the function at 5. And we cannot compute the value of the function of 5 directly, but we need to like 5 and then 4, then 3, then 2, then 1 and then 0. Once we reached at this particular specific point 0, now we can find out the value of the function at value 0 of n is equal to 0. So this will become 1. 1 multiplied by 1, answer is 1. Now you know the maths. So, we have the function of value f of 0, that is 1, 1 multiplied by 1 is 1. That is going to be replaced at this particular value of f of 1. Why? Now, because the value of the function at 1, it depends on the value of the function at 0. We have calculated that particular specific part. In my opinion, I made a mistake actually. And what is that? No, I didn't. Actually, there could be another step. There could be another step that after this f of 0, because now we start calculating the value. At this particular specific value, we apply the definition and then say that the value of the function at 0 is 1. And then 1 multiplied by 1, answer is 1. So we get the value of the function at 1. And that will be replaced by this value which is returning from the f of 0 or this particular specific last expression. So, value of the function at 1 is 1. Now, we multiply with 2 and that will give me the value of the function at 2. We get that one. Now, the value of the function at 2 is 2. 2 multiplied by 3 is 6. So, 6 will be replaced by the value of the function. Actually, the value of the function at 3 is 6. So, that will be replaced over there and then we are just simple multiplication. Now, is it clear? The mathematics don't shut your mind, try to understand a little bit. Okay, I can bear with that, a little bit understanding, but it should be, I mean, if you speak up your confusion, speak up your mind that what is confusing you, then maybe I will be able to understand, like answer those questions. Do you want to speak up? No, that's the problem. I can try to explain 10 more times, but unless and until I understand where that confusion is, I can't correct that thing. So, we get the value of the function at 4, that is 24. We multiply by 5 and that will give us the value of the function at 5. That will be 120. So, 120 multiplied by 6, this will give me the value of the function at 6. So, we compute the value of the function at 6, actually it is a 6 factorial. 6 multiplied by 5, multiplied by 4, multiplied by 3, multiplied by 2, multiplied by 1 and multiplied by 0 factorial. Normally, we stop at 1 because 0 factorial is 1. Factorial of 0 is 1. Okay. So, the algorithm is calling itself to solve the problem. The function is calling itself to solve the problem, and that is called recursion or recursive methods or recursive algorithms. When a method is calling itself, we call it a recursion or call that particular specific method a recursive method. So, it must have two parts, must have always. recursive functions, recursive methods, whether it's a mathematical equation or whether it is we are going to implement that thing, we always have a base class, just like a factorial of 0 is 1. It means we don't need, when we reach 0, we don't need to call the same method again. That link we need to stop at some point. That is called the base condition. The point when we don't do the recursion. What is the method? When say that when we have reached the value, because we are decreasing the value of n every time 1, decreasing the value. So eventually it will become 0 because we are decreasing it. Whether it is a 1 million, eventually it 1 million time, but it will become 0. So that is the base case. So we have find out that base case and find out the value, and then replacing the previous function value, we can get the value of the original one. So base case algorithm which help us to terminate that particular recursive calls. And the recursive call, if the base case is not reached, if that value has not become 0, we need to keep calling that particular specific method to solve the problem, unless and until we reach the base case. And every time we make a recursive call, we are moving closer to the base case. And if it is not the case, it means that you have some fundamental problem with that recursive method that you are trying to design, because if we are going away, it means that recursion will never finish. It will become more like a infinite loop of the recursive calls. So every time you make a recursive call, you are moving closer to the base case. Factorial, the function I show you, mathematical function. I just say that factorial long a number. It can be an integer number, it can be a short, it can be a byte, but a complete number, not double, not float. Okay? So number. And then I check. If the number is 0, give me value 1. Return. So it will return 1. If it is not the case, it is not 0, the value of the number is not 0, what we are going to do? We say number multiplied by the same method, name method. We are calling the same method in the body of the same method, factorial. We are calling the same method, factorial. But with one value less than which is coming as an input to this one. If we have given 10, next time it will call with 9, next time it will call with 8, 7, 6, 5, 4, 3, 2, 1, and then it will call with 0. Once it will call with 0, this particular specific condition is true, and now it will not make a recursive call, it will return the value. Understand? So let's see, this is our base class or base condition which will help us to stop that particular recursive call chain. And this is our recursive method. So this is a specific, what you can say that I have generated that particular specific GUI, and then I have written down that particular specific click event on this one. So I get this particular specific value that the user is giving us, convert that into the integer value because this is a string, and again we can use our try catch block to find out that we are doing it rightly or not, and then we say compute, and then we factorial whatever the answer is, we are going to show it here. That's also a label. So we say that number, that is num, and then we say that num is equal to long dot parse fact number dot txt, that text box. We are getting the text what is entered by the user, and then we are converting that into a long value. And you know that format exception can occur, so we put it in the try block, and if it is an invalid exception, I put numbers equal to 0. If that particular exceptions occur, we say make that numbers equal to 0. It means in the result part, it will show me the factorial of 0 is 1. Okay? And then I am saying that long, whatever is going to be returned by this factorial method, and if we look at that, it is going to return me a long value. Yeah? So I am just receiving that particular specific value in the factorial number or factorial results and calling that particular factorial number method. and giving that number, whatever that number has been given by the user. And then we say factorial dot label is equal to factorial of this number is whatever that contents are. So I'm just what you can say that putting those things, showing as a result to the user. Okay, so this is our part where we are getting the input from the user, processing it, converting that. Here we are doing the recursive call and getting back whatever the results are going to be received, and then here we are giving the output. Input, processing, output. Okay? And this is the factorial method that is we are going to use. So when I make the factorial 6 call, what will happen? So we have that if n is equal to, if number is equal, guys, if the number is equal to 0, no, because we are talking about 6. Okay, number is 6. It is 0, no. What will happen? It will say that make another call, 6 multiplied by factorial of 5. So 6 multiply, it will make a factorial of 5 call. Then it will make a factorial of 4 call. Then it will make a factorial of 3, factorial of 2, factorial of 0. So it has called reach at this particular specific point, making the recursive calls. The calls start from here in this method, which is a click event of the method. The result will come down here, but after all these calls has been resolved. So this click event has called the factorial 6. Factorial 6 called this factorial 5. Factorial 5 has called the factorial 4. Factorial 3 has called factorial 2, factorial 1 and factorial 0. Once we have reached at this particular specific point here, then if we look at that factorial method definition, we are saying that if the number becomes 0, return 1. So what will happen at here at this particular specific last call? Because the number num has become 0, it will return 1. So 1, it will return 1. It will return where? It will return to the method which actually it has called. Who has called the factorial 0? Factorial 1 method. So it will return back the value 1. Understand or not understand? Is it clear? No, look like nobody knows. So actually this particular specific method is being executed on the request of the factorial 1. Yes or no? Because we are making the recursive calls. Let's go back. So we are saying that user has provided me the value 6. I process that particular specific in the green part, and then in the red part I am saying that I want to call the method factorial, and that value number is 6. So we make this call. We have called this particular specific method, this method, factorial 6. Now when we call this method, what we do? We start executing that particular specific method and we check. First line, if the number is 0. Number is 0? Yes or no? Am I talking to these walls? Look like. Number is not 0. It means it will come down here in this particular specific else part, and what it will do? It will say that I want to calculate what I need to return. But for that, I need to make a call to the factorial number minus 1. Number is 6, 6 minus 1, answer is 5. So it will make a call to the method 5. So factorial 6, that is a method which is currently we are executing, it will make a call to the factorial 5 because it want to compute in this particular specific line. If I just try to control P, at this particular specific line, it want to calculate what it need to return to this click event method. But for that calculation, it need to call the what you can say that it need to call that particular specific it need to make a call to the factorial 5 method. Making sense or not? It's a number multiplied by factorial number minus 1. So 6 multiplied by, it need the value of the factorial 5 function. So it is making a call to the factorial 5. Again, we come back to the same method. Now a new copy, you can say that. A new copy of the same method has been executed, starting from the very first line. If the number is 0, now the number is 5. Making sense or not? Now the number has been decreased. A new copy. It is the same method, because definition, we just like we have a class and we can create as many objects we want. So it is the same method, but a new copy has been created. And then we start executing on the very first line. Then again check if the new value, that is a 5 is 0. No. Again we say that 5 multiplied by factorial 5 minus 1. It means to what we need to return from this method, that depends on the factorial 4. So it make the call to the factorial 4. Similarly, we will continue. Now the number has become new copy or the third copy of the factorial method. Now again check 4 is 0. No. It will make 4 multiplied by factorial 3. 3 multiplied by factorial of 2. That's what we need to return to the previous method, which actually he has called. And then I say that 2 multiplied by 1 or factorial 1. 1 multiplied by factorial of 0. And once we have reached that factorial 0, actually it starts returning the value. So from this point, instead of making the recursive call, we say that return 1. It means that one value, I will just try to convert that into the, so this 1 is going to be returned to the factorial 1. And where we are at that particular specific line, at this line. Can I just remove that one? Select pointer or highlighter? No. Okay. Anyway, so I come at that particular specific line back. Factorial 0 has returned me 1. I say 1 multiplied by 1. That is become 1. Now this value will be returned to the factorial 2, who has called this method. 1 has been returned. 2 multiplied by 1 is 2, and that is going to be returned to the factorial 3. 3 multiplied by 2, that is 6. That will be returned to the factorial of 4. 4 multiplied by 6, that is 24, and that will be returned to the factorial of 5. 120. 120 multiplied by 5, that will become whatever that value is, and that will be returned to the factorial 6. So 120 multiplied by 6, and that will become 700 and something, and that is going to be returned to the point where we started that particular specific thing. So now in this particular specific, what you can say that this math variable fact underscore result has received the factorial value, that 720. What 7? Okay, and now we are using just to show on the output 720. So at this point we make a math call factorial 6. No, it's not. I'm not saying that fixed number. Whatever the value is being given by the user in this particular specific box, that is going to be used. I mean, right now I'm just using 6 as a value, maybe 10, maybe 20. But remember, if I just give 9, that 720 will become a very big number. If I just go 21 or 15, that will become even larger number, because we are multiplying. Okay, so it's 6 is just, I'm using an example. Okay, it's just a random number, you can say whatever. Okay, So I just say that from this point we make the call to this one. So when we are making all these calls, factorial, 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 we are making the copies of these methods. That particular specific call are being handled. You know, we are executing the multiple program, even we are also executing the compute factorial click. Underscore click. This is a method we are executing. This method is going to be saved in the program stack, because at this particular specific line we have started execution of the factorial method. So what will happen with this method, which is we are currently executing, we have, for example, we have only one processor, or maybe we have multiple processors, but this program has stopped because it is waiting for this factorial method to give back the results, and then it can continue the execution. Otherwise it can't. So this method will go into the program stack. You know stacks? We talk about a stack, it's a first in last out data structure. Okay, so it will go into a program stack with the current information. It has the value number, which has the value 6, for example, and then it is executing which specific line. It is executing that line. We don't come and start executing from the start. So this is the state of that particular specific method or the program that is running in your system. That is a state. We are running line number, for example, 1, 2, 3, 4, 5, 6, 7, line number 7. That's where we are calling this factorial method. What is the value of this particular specific variable? So we save all those information in the program stack, and this is our program stack. This method, that is the click event, that's right at the bottom. And now we have called the factorial 6. What will happen? This factorial 6 is going to appear. I mean, now we are executing, and once we have reached at this particular specific point, we say num, that is 6, multiply by factorial of 5. So once we do that, again we need to stop the execution of the factorial 6 method or factorial method with the num value 6. So it will save that particular specific current state of that method. What is the value of the num? That is 6. And which line it is executing? 1, 2, 3, 4. It is executing line number 4. So these information are being saved in the program stack, because at this point we make a new call to the factorial 5. So this information, which line we are executing, what are the values of the variables, all these information which are related to these methods, they go into the program stack. Making sense? And now we are executing the factorial 5. And again, this is a new method, a new copy of the method, you can say that. So it will start again. If the number, that is 5 right now, is the num is 0? No. Again we come down here. 5 multiply by factorial 4. Once we make this call, this factorial 5 is also going into the program stack. And now we are executing the factorial 4, again starting from 0, new copy of the method. 4 is 0? No. 4 multiplied by factorial 3. Once we make this call at this point, this particular factorial method again will go into the program stack. And in this way we will continue. Factorial 3, it will call factorial 2, factorial 2 will call the factorial 1, factorial 1 will call factorial 0, and once we have reached at this point, this will, a new copy, a fresh copy, it will execute this line, because now the number has become 0. If the number 0 is 0, yes, it is true, return 1. So once this particular specific method it will return to the point where it was called. Who has called the factorial 0? That is a factorial 1. So it will return the value 1 to the factorial 1. Where? At this point, at this line. from the line where it was called. So now the factorial 0 has returned 1, 1 multiplied by 1, 1 that is a number value, and 1 that has been returned by the factorial 0. 1 multiplied by 1. Now we have computed the value that need to be returned. And where it will be returned? To the method which has called factorial 1. Who has called factorial 1? Factorial 2. Understand? And again, factorial 1 has returned 1. That will be replaced at this particular specific point. Value of the num is 2. 2 multiplied by 1. Now we have computed that expression. 2 multiplied by 1 answer is 2. Now we have a value that we need to return. Where to return? Who has called this method factorial 2? That is factorial 3. Change to 3. And similarly, we are going to return the values to the method which has called, and we have reached to the factorial 6. Who has called the factorial 6? This method here. This particular specific method has called the factorial. So it will stop executing the factorial 6 method and start executing the compute factorial underscore click method. And the value 720, it will be returned at this point after that equal sign. After the equal sign. And now this value 720 will be assigned to the variable fact underscore result. And then eventually we are going to show the results to the user. Okay? Does make sense that what's happening in that program stack and how being recursive call are being made, and then return values are coming back? Nothing. Look like nothing, or maybe a little bit. Okay? So let's talk about another recursive call, and then we are going to design that one. We are taking the power. Now we don't have one variable, we have two variables. We say f of x comma n. X will remain same. Look, definition say that, the definition, it say that if the value of n is equal to 0, his answer is 1. Anything raised to power 0, mathematical equation, don't shut your mind. It is a simple fact that anything raised to power 0, answer is 1. 1 million raised to power 0, it will become 1. Doesn't matter what the value of a is, x raised to power 0, answer is 0, 1. So whenever the value of n is 0, that function will return me 1. Otherwise, we are making say that x multiplied by f of x n minus 1. That's what we need to do. So first we need to, this is a power method, okay, that we want to create. Of course, we can use math.po and then give those two values and it will return me back, but we want to do it ourselves. So I just come down here in my Windows environment. I have put that particular specific, the compute factorial one over there. I have the factorial. So now I have already generated that particular specific, power. We can give some value here and then we can compute some power. But now we need maybe two values, or maybe we can fix one value. So maybe we can fix one value, and what is that? We say that int x is equal to, for example, favorite number 6. X, we fix that particular specific number. And what power we want to compute, we will ask the user. Understand? Does it make sense? So now, first of all, we need to make that particular specific method. So I say it's a private method. Okay, fine. It is going to return me a long value because raised to power something is a big value. So instead of int, I say long. And what else? It's going to return me a long value. Now we need to compute power. And it will take two values as input, int x and int num. Sorry, it should be coming down here, int the power. or the number. It should be int. Okay, so I'm just trying to, why it is giving me this underline, because it say that you need to return a long value and you're not returning anything that, okay, but we will see. Now, what is a base? Base, first of all, we need to design that particular specific base condition where we are not making any kind of a, what you can say, that recursive calls. What is a base? For n is equal to 0, or if in this case we are saying that for the num is equal to 0. So we can say, what we say, if I just try to put that one here so that you can see this one as well, and then you can guide me that how I can design this one. What we need to do, what I need to check, what I should do here. You say that 0, when number becomes 0, what we need to do? Huh? Return 1. So when that particular specific num is 0, we need to return 1. Yeah? Okay. So we can write what? If not null, num is double equal to 0, return 1. And we can put a L here. Is it so? Okay, yeah. Okay, no. I will just try to remove that one. So we need to return 1. And what we need to do in the else part? We can go to the definition. What we need to do in the else part if it's not 0? I mean, we need to do n minus 1, yes. What we need to do? If I just give you this definition, ask me, give me the recursive calls method, so what we need to do here? Sorry? X times n minus 1. So you are saying that we should do something like that, x times or say return x times n minus 1. Oh, sorry, num minus 1. Where is my? So say num minus 1. Is it so? Of course, we can put that semicolon over there as well. Is it so? That's what we need to do. X multiplied by num minus 1. Huh? Missing the factorial? What is the factorial? So we say something like this. Factorial like this. We are calling the factorial method, not the compute power method. Guys, what we need to do in the recursive call? Yes, please.
You need to call itself.
First of all, we need to compute, not factorial. Not sorry. Compute power. And what we do, if we look at, if we just go back here, we are providing the same value of the x, but with the one less value of the n. So we provide the same value of x and n minus 1. If number is 0, num is 0, or I can say that is, I think we just to confuse, remove that confusion, I put that n. If the n is 0, give me back the value of the function or value of this method as 1. Otherwise, return x multiplied by whatever that power the recursive call, x into n minus 1, x comma 1 n minus 1. So that is going to be the recursive method, because we need to call the same method. So we simply say that whatever that particular f, that will become the name of the method, and these are the parameters, and this is whatever it is. This is x times the function of x comma n minus 1. So that is exactly what we're doing, x times function or the method of x comma n minus 1. Okay, and now what we need to do, compute on click. So we just need to go there and click on that one. So we say power number. Okay, this is the power number. So we can simply say that try, and then we can say that I just try to make this particular specific here, n is equal to 0. Okay, and then we say that n is equal to int dot parse, and then we say power number dot text. Okay, so I give the value from that particular specific text box and convert that into the integer value and put that one over there. And in case there's an exception, catch, I say exception e, and then I just say that message box dot show, I will just say e dot message. In case that exception occur, I can use that one, exception e. I think that it is also that event argument e, so we can't use ex, so we say that ex. We can't have the two variables in the same scope with the same name. Okay, and then what we need to do, we need to call this particular specific compute power method. So we can say that long result is equal to compute power, and then we give the value x and n. It will do the recursions, give me back the result, and after that what we need to do, we need to go back here. We have the label power, and what are the names? We have power label and power result. So we can say that, where is my method here? So we can say that power label dot content is equal to what? Power of plus x plus power of x to n. Okay, maybe I can just put one more thing here, plus is. Okay, and then say power result dot content is equal to result. We can check, yeah, I think that's, we can just directly put there that it will automatically convert that into the string and show over there. So let's run it and see. We are, remember that x is 6, 6 is to power, we are computing 6 is to power 2 is 36. So we will just try it. Okay, we have an error, and what is that? We are saying that fe is declared. Okay, this is already contains the definition of the compute power. Okay, where is the error list? So I just go into that particular specific line, line number 29, line 29. Okay, power label. Okay, where is the power label? fact label. Okay, I say power 1, just I don't want to find where that particular specific thing is, and then say that power label power 1. Okay, we just change this one, and then see that. Compute power. Okay. Click compute power. Okay. Where is the compute power? Okay. I just try to remove that thing. I don't. Let's see if it is going to work or not, huh? Yeah, hooray, it's working. Not yet. No issue found. It is executing somehow. It is coming. Look. So we can say that, and for you, it's I can give anything here. I can just put 8, so it will compute the factorial 8. So okay, and then here I'm giving, for example, 2 and compute 36. Okay, and then I say 4, it will compute 6 raised to power 4, and the answer is there. Okay, so that is the end of our lecture on the recursion. Recursion is calling the same method again, and we also understand how that recursive calls are being managed by the operating system using the program stack. Okay, so that's all. Thank you very much.